Friends, in this session we will have a broad overview of simultaneous linear equation with graphical explanation. Let us say we have two linear equations in x and y, a1x plus b1y equal to c1 and a2x equal to b2y equal to c2. Now we have to find out how many solutions will be there for this set of or pair of equations. Now we know standard form of linear equation is y equal to mx plus c, where m is the slope. So if we transpose y equal to mx plus c in any of these two, a1x plus b1y equal to c1, we get y equal to minus a1x by b1 as the slope. Y equal to, by transposition we will get y equal to minus a1x by b1. So the slope can be understood as minus a1 by b1 for the first line and minus a2 by b2 for the second line. Now let us see how these lines will give us solutions. Now these two lines, a1x plus b1y equal to c1 and a2x plus b2y equal to c2, firstly they will give us a unique solution if a1 by a2 not equal to b1 by b2. Let us see what happens if a1 by a2 equal to b1 by b2. Suppose a1 by a2 equal to b1 by b2, then the slope of the two lines will be equal. So when the slopes are equal, then the lines will not intersect. Hence, if the slopes are not equal, we will get two different lines. Any two different lines in a plane will have to intersect at some point. So we can show this as intersection point, and the point of intersection is the common solution of both the equations, which gives us x1 and y1. I repeat, if a1 by a2 not equal to b1 by b2, then the lines are not parallel. If the lines are not parallel, they will intersect at some point, and that point will be the solution for both the equations. Now what happens if a1 by a2 equal to b1 by b2 equal to c1 by c2? a1 by a2 equal to b1 by b2 equal to c1 by c2. Obviously, then we have only one line. Both the linear equations represent only one line. So the graph will be something like this. We get only one line, which is the graph for both the equations. Now if we take any point on this line, let us say point with coordinates x1 and y1, this will also satisfy both the equations, and we take the other point x2, y2 on this line, this will also satisfy both the equations. The third situation, the two lines will have no solution if a1 by a2 is b1 by b2, but they are not equal to c1 by c2. What happens in this case? Well, in this case, since a1 by a2 is b1 by b2, the lines are parallel. But since c1 by c2 is not same as b1 by b2, so the lines will be different and not the same. So we will have parallel lines. Once we have parallel lines, for one value of x1, I get two values of y1. x1, y1 will satisfy the first equation, and x1, y2 will satisfy the second equation. So there will not be any solution which is common for both of them. Just as an explanation for the second one, where we said that if a1 by a2 is b1 by b2 is c1 by c2, we have only one graph, so infinite solutions. Let us see. Suppose the first equation is x plus 2y equal to 3, and the second one is 2x plus 4y equal to 6. Then a1 by a2 is 1 by 2, b1 by b2 is 2 by 4, and c1 by c2 is 3 by 6. Now you can see that 1 by 2 equal to 2 by 4 equal to 3 by 6. Look at the equations. If you multiply the first equation by 2, you get the second equation. So in effect, we are having only one equation, which is what we said in this graph, that we are having only one equation. So there is an infinite number of solutions. Let us go back to the third explanation. We said there is no solution if a1 by a2 is b1 by b2, but it is not equal to c1 by c2. As an example, if we take x plus 2y equal to 3 and 2x plus 4y equal to 5. Now we can see that these are two different lines, but slope of the two lines are same, because the slope, as we discussed earlier, is minus a1 by b1 for first line and minus a2 by b2 for the second line. So the slopes are same. If the slopes are same, the lines will be parallel. So for this equation, we'll get a graph like this, two parallel lines which are not intersecting, and hence no solution, because if I put x1, then from the first line I get the value of y1, but y1 will not satisfy the second equation. Similarly, if I take x1 here, I'll get y2 from the second equation, but this value of y2 will not satisfy the first equation here. Hence, I think the concept would be clear to you. Cheers.